So this is question number 25 of GATE Metallurgical Engineering 2021. So the question is, the vacancy concentration in a crystal doubles upon increasing the temperature from 27 degrees Celsius to 127 degrees Celsius. The enthalpy in kilojoule per mole of vacancy formation is, and the value of R is given as 8.314 joule per mole per Kelvin. So in order to understand the detailed concept behind this problem, you can refer week 5 on vacancies of Introduction to Material Science and Engineering course by Professor Rajesh Prasad, Department of Applied Mechanics, Indian Institute of Technology, Delhi. So let us first understand the equilibrium concentration of vacancy. So how this concentration of vacancies varies by changing temperature. So if you define this equilibrium concentration as NEQ, so it will be equal to N into the exponential of minus HF upon RT, where NEQ is the equilibrium vacancy concentration, N is the total number of atoms, delta HF is the enthalpy of formation of one vacancy in joule per mole, R is the gas constant in joule per mole per Kelvin, and T is the temperature in Kelvin. Now, since we have been given two temperature conditions, so we will try to calculate the value of NEQ for both the temperatures in order to get the enthalpy. So, we have been given T1, the first temperature 27 degrees Celsius, but in the formula it is in the Kelvin, so we need to convert it into the Kelvin by adding 273, so it will finally give 300 Kelvin. And the equilibrium concentration of vacancy at this temperature is, let's say, X and denoted by NEQ dash. Now, at the second temperature T2, which will be equal to 127 plus 273 equals to 400 Kelvin, with the equilibrium concentration of vacancy doubled at this temperature, that is 2x. Now, as the value of R already I have mentioned, the value of R will be equals to 8.314 joule per mole per Kelvin. So we will try to take the ratio of the equilibrium concentration of vacancy at temperature T1 and T2. So which will be equals to N into exponential of minus delta HF upon R with the temperature 300. Similarly, N equilibrium concentration at T2 with temperature value equals to 400. So I have simply put the value of T in this formula, where T1 with 300 and T2 as a 400. Now if you put the value of all this thing which we have been given in the problem, we will get N equilibrium bar as a X and N equilibrium double bar as a 2X with EXP delta HF upon R 1 upon 400 minus 1 upon 300. If you solve this, we will get an expression like this, and if you further simplify this, we will get delta HF as 1200 R into ln2. So by putting the value of R as 8.314 and ln2 value, we will get the delta H value equals to 6915.39 in joule per mole. But in the question, if you closely look, they are asking enthalpy value in kilojoule per mole. So we need to convert this value into kilojoule per mole by dividing 1000. So if you divide this value by 1000, you will get the delta HF value in kilojoule per mole, which is equals to 6.91. So finally we got the value of delta HF equals to 6.91 91 kilojoule per mole. So that is the correct answer for this problem. Thank you.